First of all, you guys must know what is differentiation. Differentiation is a fundamental concept in calculus that deals with how a function changes as its input or variable changes. It measures the rate at which a quantity changes. The rate of change of function is defined as dy over dx. Next, we go to application of differentiation. The application is maximum and minimum, Rolle's theorem, related rates, mean value theorem, and determining increasing and decreasing functions.
Then we move on to applied maximum and minimum problems. What is applied maximum and minimum problems? Applied maximum and minimum problems in differentiation are used to find the optimal values of a quantity in real-world situation. These problems involve determining the maximum or minimum value of a function within a given set of conditions. These problems make use of the concepts of differentiation to analyze and determine the best possible outcome. In the context of calculus, differentiation helps in finding the rate at which a quantity changes. By analyzing the derivative of a function, we can find the points where a function reaches its maximum or minimum values.
So the next one is the objectives of applied maximum and minimum problems, which is to optimize a particular quantity within a set of constraints or conditions, either by maximizing or minimizing it. And the goal is to identify the best possible value of the function that represents the quantity in questions, such as profit, cost, area, volume, distance or speed under given circumstance. So next, moving on to why we use applied maximum and minimum, which is to maximizing or minimizing a particular quantity that can help us find the optimal solution in many practical scenarios. It also helps us to make decisions that lead to the best possible outcome, and there are limited resources, including money, materials, times, and also we want to make the most efficient use of them. We also can determine how to allocate resources in the most effective way. And lastly, we would want to minimize production costs while still meeting the demand and want to maximize the return on investment with limited funds.
Problem statement. A coffee shop is trying to determine the optimal price for a cup of coffee to maximize its daily revenue. Based on market research, the shop observed that revenue is influenced by the price per cup. Increasing the price leads to higher revenue initially, but beyond a certain point, the number of customers decreases, reducing revenue.
Hi everyone, today we will solve a problem regarding our topic, which is differentiation in economics. The question states a coffee shop has observed its daily revenue depends on the price of coffee as the equation given. Rp equal to negative 15p square plus 500p, which is Rp is equal to revenue in ringgit Malaysia and P is equal to price per cup in ringgit Malaysia. For those who doesn't know what is revenue, revenue is refers to hasil. So the first question states that we need to find the price per cup that maximize daily revenue. So what we need to highlight here is price per cup that maximize daily revenue. So to solve this question, we need to find the differentiation of the original equation given and equal it with 0. So we need to find negative 15 P squared plus 500P equal to 0. So what we need to do is solve like we learned before. Bring the power to the front and times it. And the power is minus by 1. So what we get here is negative 100p plus 500 equal to 0. For those who ask why the p is gone, we need to remember anything that power with 0 will equal to 1. So what we need to do next is find the value of p. We bring the negative 100p to the right hand side, so it will change to positive. So 100p equal to 500. So p equal to 500 divided by 100. So price for a cup of coffee is 5 ringgit. Settle for the first question, and we proceed with the next question. The next question states we need to calculate the maximum revenue. Since we know the price of a cup of coffee is 5 ringgit, we need to substitute it into the original equation given. So we need to substitute p equal to 5 into the original equation, which is Rp equal to negative 15p squared plus 500p. So what we can get here is so the value of maximum revenue is 1,250 ringgit. From what we calculate is we can conclude that the daily revenue for a coffee shop maximum they can get is 1,250 ringgit. I think that's all for this question. Thank you.
Conclusion. In conclusion, differentiation serves as a powerful tool in economics, enabling us to understand and solve a variety of complex problems, from optimizing profit and cost function to finding equilibrium points in market analysis. The applications are both diverse and essential. The technique of finding maximum and minimum values through differentiation allow economists to make informed decisions and predictions about market behavior, resources allocation, and production efficiency. By applying differentiation to real-world scenarios, we can see its practical value and its significant impact on economic theory and practice.